Hi folks, we're going to take a look at an example of solving a rational inequality, and we're going to take a look at number 2 from the Unit 2 assignment. So here they give us this inequality here, and while it might be very tempting to factor these expressions on the left, that's not going to be of much use to us because that's only useful when I've got 0 on the other side of the equation and I'm determining whether a rational expression is positive or negative. All right, so step number 1 is to bring that 3 to the left-hand side of the equation and then work with it from there. So x squared minus x minus 2 all over x squared plus x minus 2 minus 3, and then greater than 0. So step 1 is to set it up so that you've got everything on one side of the inequality. Step 2 is to rewrite what you have on this left side as one single rational expression. All right. So here I'm going to do this using a common denominator of x squared plus x minus 2. So here that factors already in the first fraction, so I'm not going to multiply this numerator by anything. So x squared minus x minus 2 minus, well, the 3 is missing this denominator. So if I want to have x squared plus x minus 2 in the denominator here, I also need to multiply the numerator by that expression. So 3 times x squared plus x minus 2 all over my common denominator. All right, and so now what we have is a single rational expression, and we need to determine when it's greater than 0. Okay, so our goal now is to find the zeros of the numerator, the zeros of the denominator, because those are going to give us our x-intercepts and our vertical asymptotes of this rational expression as a function, and from there we know those are the only places it can change sign. All right, so let's start by simplifying the numerator. So here x squared minus 3x squared is negative 2x squared. Here I have negative x minus 3x, so negative 4x. And then here I've got negative 2 plus 6 is plus 4. All right. Might as well factor the denominator here. That's an easy one to factor. So it's going to be x plus 2 times x minus 1. All right, greater than 0. And so now my goal is to try to factor this. And if I can't, that's okay, because it's a quadratic, and I can always use the quadratic formula to determine where it's equal to 0. Okay, but to make my life easier, I see that there's common factors here. So I'm going to factor out a negative 2 from all three terms, and then I'm going to divide both sides of the inequality by negative 2. Okay, but remember that when I'm dividing by a negative number, I'm going to have to change the sign. So again, you see me doing this all in one step. You might want to show that step, first factoring out the negative 2 and then dividing both sides. But as you get more proficient with the algebra, you hopefully don't have to show all these steps. Okay, so what happens when I factor out a negative 2? I'm going to be left with x squared. Negative 4 divided by negative 2 is going to be plus 2x. And then 4 divided by negative 2 is going to be minus 2. Okay, all over x plus 2x minus 1. And I'm dividing both sides of that inequality by that negative 2. So this is going to be less than 0 divided by negative 2, which is still 0. Okay, so again, if you think you might make some mistakes in that process, you might want to show an extra step here. All right, so I have the places where this is not defined. You know, they would relate to being vertical asymptotes of this as a function. Unfortunately, the numerator is not factorable. Okay, so on the side here, I'll determine the values at which it's equal to 0. So here we have negative b plus or minus square root of b squared minus 4 times a times c all over 2a. All right, so here, let's simplify. Negative 2 plus or minus, this is 4 minus negative 8, so 4 plus 8 is 12. All right, and here I might as well simplify just to make my life a little easier here. So negative 2 plus or minus, this is 12, it's 4 times 3, so square root of 4 is 2. Left with root 3 there. And this, of course, simplifies to negative 1 plus or minus root 3. Okay, now what I'm going to do is I'm going to determine approximations for this because I'm going to want to put this on my number line. So get a sense what these numbers are. So here we have negative 1 plus square root of 3, and that's about 0.73. And then we've got negative 1 minus square root of 3. And that's about negative 2.7. Okay. Now, in order to determine the sign of the numerator, I don't want to actually have to plug in numbers into this expression, and I don't need to because this is just a parabola, upward facing because of the positive leading coefficient, and I have my 2x intercepts. So I'm just going to draw myself a little graph here. You might have seen me do this already in the past. I'm just going to draw a little graph. It's going to be my little reminder of when this is positive and negative. So upward facing parabola, and here we have negative 2.7, and here we have 0.7. This is where it changes sign. All right, so I'm just going to use this as my guide. So now I'm going to, on my number line, make it long since I've got lots of numbers here. So the smallest number I'm dealing with is negative 2.7. Then I've got negative 2. Then it looks like 0.73. So I'll just put 0.7. And then we've got 1. Now, because these numbers here relate to vertical asymptotes, in other words, the expression doesn't exist, I'm definitely not going to include those. I would never include those. And here, because I'm looking for strictly less than 0, I'm also not going to include my x-intercepts because I'm not interested in when it's equal to 0. All right, so now let's go ahead and do our testing here. So let's say you take something like negative 3. All right, so if I look at the numerator, negative 3 is on that side, so the numerator is going to be negative. And if I look at the denominator, negative 3 plus 2 is negative, and negative 3 minus 1 is also negative. So what do we have? We have negative over positive, so negative in this interval. So let's pick something here. Let's say negative 2.5. Okay, well, negative 2.5. Sorry, I just realized I made a mistake here because, sorry, this is positive. I'm not sure why I said that was negative. So this is positive over positive. So sorry, that's positive there. Good thing I caught that. See, so this is why having the graph is nice, because then when I went to the next one, I immediately caught my mistake instead of trying to do this in your head. All right, so let's go again. I'll be a little more careful here. So negative 2.5 would be here. So that's negative in the numerator. And in the denominator, well, negative 2.5 plus 2 is still negative, and negative 2.5 minus 1 is negative. So negative over positive, that one's going to be negative. Here in between, well, I'll take 0. That's nice and easy. 0 is clearly going to be negative for the numerator. And in the denominator, 0 plus 2 is positive, but 0 minus 1 is negative. So negative over negative, positive. Okay, so here let's take something bigger than 0.73, say 0.8. So 0.8 here would be positive on this side here. And here we have 0.8 plus 2 is positive, and 0.8 minus 1 is negative. So we have positive over negative is negative. And lastly here, let's say we pick 2. Well, positive on the numerator, and in the denominator, well, both of them are positive. All right, so there we go. We had a lot to test because we had 4 different places where this expression could change sign. So now I need to determine where this expression is less than 0. It's going to be in these 2 intervals. Now, when I give my answer, given that this was a straight math problem, it makes sense to give it with exact values. All right, so my solution is x is an element of the following sets. So between negative 2.7 and negative 2, but I'm going to actually use negative 1 minus root 3. Okay, I'll use the more official solution. So negative 1 minus root 3. Okay, and then all the way to negative 2. All right, notice I'm not including either of those endpoints. And then union this interval here, where it's also negative, excuse me. So that's between 0.7 or negative 1 plus root 3, and here 1, not including. Okay, so let's do a recap. Now, by the way, had you not divided by that -2 and left the inequality as it was, you should have opposite signs on all of your intervals, and you would have still gotten the same end result because you would have been doing a greater than 0. So let's do a recap here. So step number 1 is do not, under any circumstances, multiply both sides of the equation by the lowest common denominator. And that's because this expression is sometimes positive, sometimes negative. And so you'd have to start considering different cases if you were to do that. So our alternative is to bring all terms to one side of the inequality, get 0 on the other side, and write the left-hand side as one single rational expression, which you can then factor, or in this case here, use the quadratic formula to determine where either the numerator or denominator is equal to 0. And once you've determined all the places where the expression could change sign, you just have to test a point in every one of those intervals. And then from there, you can read your answer from the graph. All right, that's it for this one.